Okay, and as always, the lectures will be recorded. You can view them later on the YouTube channel. Okay, so we stopped at rational functions. The next thing to go through, yeah? 160, yes. Okay, sure. Okay, yeah, please check the timetables, okay, for your lectures. So on the learn page, I've got just for the maths for you guys. But if you talk to Mr. Evans, you can get the full timetable. Do you have that with you? You've got the full one. Okay. Okay, so inequality, what is an inequality? Well, we know what equality means. X equals 2 means x equals 2. It can only be that value. And inequality is not equal. So it's bigger than something, less than something, not equal to that. So we can write it as, just as an example, 1 is less than or equal to x, less than 2. So here x does not have some one specific value. X can be anything between 1 and 2. And what this first symbol means here, less than or equal to, means it could be equal to 1. On the right-hand side here, this is a strict less than. In maths, whenever you hear the word strict or strictly, it means not equal. Like definitely not equal. So on the left-hand side, that is less than or equal to. On the right-hand side, it is strictly less than. In other words, cannot be equal to. Okay, so in words, we can say x lies between 1 and 2. And just to qualify that, definitely not 2. So not including 2. Okay, but we didn't say anything about 1, so x can be 1. Okay, we can also write this on a number line. So we all know what the real number line looks like. It will be something like this. Going to the right is infinite, going to the left is infinite. You've got all the numbers. Let's just put a few. So let's say 0, 1, 2, 3, minus 1, minus 2, and so on. You know that. We can write this inequality as an interval. An interval is just a section of the real number line. In this case, it's going from 1 to 2. So we say from 1 to 2. A closed dot means it is inclusive. So it could be 1. An open dot or open circle means it is not possible to be 2. So this is how we represent the same inequality, but as an interval. Okay, that's just a picture of the interval. We could also represent the interval another way by writing square bracket 1, comma 2, round bracket. So square bracket, again, means inclusive. So if we look at all three variations here, less than or equal to, it could be equal to, colored in dot could be equal to, square bracket could be equal to. And on the other side, strictly less than, it can't be equal to that. Open circle cannot be equal to that. Round bracket cannot be equal to that. Okay, 3 ways we've said the same thing. Okay, so again, square bracket, this is including. So including 1, round bracket, excluding 2. Okay, but everything in between, perfectly fine. Okay, everyone okay with those 3 representations? Okay, for tests and assessments and so on, you can use any of the 3, I don't mind. Okay, that's up to you. As long as it's right, I'm happy. Okay, first thing, a linear inequality. Okay, so we'll go through this just by examples. It's really not too difficult. So example number 1, we have minus 2x minus 3 is less than 5x plus 1 minus 12. So linear inequality. Inequality is obvious. We got an inequality sign over there. What makes it linear? All appearances of x is linear in x. So you've got linear, which is just x, quadratic, x squared, cubic, x to the 3. If there's only x, nothing else, then it's called linear. So linear inequality, only x terms, and then you have some sort of inequality. Less than, greater than, less than or equal to, greater than or equal to, one of those. Okay, aim of the game is to find the possible values of x, right? Just like an equation, you want to solve for x, but in the case of an equation, it's one value of x. Okay, here it's going to be some interval because of the inequality. So what do? Well, we simplify as much as possible and we end up with the answer. So on the left-hand side, we can write this as minus 2x plus 6 is less than 5x plus 5 minus 12. Okay, just expanding things out there. We can do a bit of rearranging. We want the x's on one side, everything else on the other side. So we can write this as 6 plus 7, taking the constants from the right-hand side over, is less than 5x plus 2x. Okay, constants on one side, variables on the other. We can simplify further. So 13 is less than 7x. So 13 over 7 is less than x. Or x is greater than 13 over 7. Doesn't matter which way you read it. So you can write it like this. Or if you want to write it using an interval, you can do that as well. This is strictly less than. So round bracket, 13 over 7. And then going up to what? Well, it doesn't say it's less than anything. So it can be all the way up to infinity. Not including infinity because that's not a number. So infinity always comes with a round bracket. Okay, if you ever put infinity with a square bracket, I'll mark the whole thing wrong. Move on to the next question. Okay, infinity is always round bracket. It's not a number, it cannot be equal to that. Okay, example 2. We have 2, 1 minus x plus 5 is less than or equal to 3, 2x minus 1. Okay, again, looks complicated. We just expand it out. X to the one side, constant to the other side, and we get our solution. So on the one side, we get 2 minus 2x plus 5, less than or equal to 6x minus 3. Okay, so we got everything individually now. X's to one side, it doesn't matter which side, constants to the other. So we're going to end up with 7 on this side, plus the 3 from the other side, 6x from this side, and then plus the 2x from the other side. So 7 and 3, that'll be 10. 6 and 2, that'll be 8. Taking the 8 across, we get 10 over 8 is less than or equal to x. You can simplify if you want. Okay, you have use of your calculators if you need. So 5 over 4 is less than or equal to x. Okay, again, you can write it like this, perfectly fine. If you want to write it as an interval, you can. Here, it's less than or equal to, so square brackets, 5 over 4. There's nothing stopping x from being as big as it wants. Okay, on the right-hand side, there's nothing there. So this goes up to infinity, round bracket. Okay, again, round bracket with infinity, please. Okay, that's it for linear inequalities. Any questions? Yes? If it was negative, there would be a sign change, yeah. Yeah, so just on the side here, if we had 10 is less than or equal to, let's say, minus 8x, then we would have minus 10 over 8 is greater than or equal to x. It would swap. Okay, so this is just a sign change. Okay, but that's not important for this problem. Okay, any other questions? All good? Okay, next one, polynomial inequalities. Okay, so same idea as before, but instead of just having x and some constants, polynomial can now be x squared, x cubed, x to the 4, something like that. Again, we'll just go through it by example. So number 1, let's say we have x squared minus 10 is less than 3x. Okay, so polynomial, right, x squared, it's more than linear. So what does this mean? We'll see this later on. You don't need to know it for now. But if we were to sketch these two graphs, so x squared minus 10, that's going to be something like that. 3x, something like that. Okay, we've got these two intersection points here. And the question we're asking is, where is the straight line that's on the right above, right, the parabola? That's how you can read it. Or where is the parabola below the straight line? That's how you read these statements. So parabola being below the straight line, you look at all the points. Between the two dots there, you see that the parabola is below the line. On the right-hand side, the parabola is above the line. On the left-hand side, the parabola is again above the line. So we're interested in this region here. Okay, this part in yellow, where the parabola, that's this part, is below, less than, the straight line. Okay, so this is just a geometric view of what's going on. To answer these problems, you don't need to know how to sketch it, but later on, we will be looking at the sketches. Okay, so what we want is where it's below. A good starting point is to see where they are equal. So that first dot there and the second dot there, if we can find where those are, we're just looking for all of the x values in between them. Does everyone see that? If we get the first dot and the second dot, the solutions are between the two. So where are they equal? Okay, that will give us the two dots, and then the solutions lie between them. So let's see where x squared minus 10 is equal to 3x. That will give us that point over there and that point over there. Right, this is quadratic, and we want to find 2 points, 2 solutions to the quadratic. So we're going to have x squared minus 3x minus 10 is equal to 0. Easy stuff to do. Factors of 10, 5 and 2, that'll give us the 3. So that will be x plus 2, x minus 5, right? Because we need the negative, is equal to 0. So we get x equals minus 2 from the one factor, x equals 5 from the other factor. And now just by ordering those, we know which one comes first. So this dot here on the left, that must be the smaller one. That must be the minus 2. This dot on the right, that's the bigger one, so it must be 5. So our solutions are between minus 2 and 5. And we just go back up here. This is a strict less than, so it's not equal to the endpoints. So we have minus 2 is less than x less than 5. Or if you want to write it as an interval, minus 2 to 5, not including either of the endpoints because of this inequality here. So always keep in mind what you're working with. Is it less than, or is it less than or equal to? That will change what you have. Okay. Any questions so far? All good. Okay. Next one. So that was example 1. Example 2. Yeah, 2. Okay, so we want to solve for x such that x squared minus 5x is greater than or equal to minus 6. Okay, so again, we can do a little sketch of what's going on. All right, not needed, but if you want to, you can add it. Okay, x squared minus 5x, we can sketch that. It'll look something like this. Okay, something just shifted across. And then y equals minus 6 for that right-hand side. That's just going to be a horizontal line. Something like that. Okay, so what are we looking for? We're looking for where the parabola is above the line. So if we just look at these two intersection points, between the two intersection points, the line is above the parabola. We're not interested in that. We want the other points. So we look to the right and to the left. So it's going to be this bit here and this bit here. Okay. Again, between the 2 points, the parabola is below the line. But look what we want. We want parabola above the line. So it must be outside. Okay, what are these 2 points? Well, that's where the two functions are equal. So let's solve for that. So x squared minus 5x is equal to minus 6. Minus 6. Okay, we just take the minus 6 over, and then it just becomes a simple quadratic two factor. Plus 6. Okay, factors, well, we want 5, so that's going to be 2 and 3. Okay, so that will be x minus 2, x minus 3. Right, because the minus 2 minus 3, that gives us the minus 5, and the product is 6. Okay, so we get two solutions. X is 2, x is 3. Again, ordering them tells us which dot comes first here. So this dot here on the left, that must be 2 because it's smaller. And the one on the right, that must be 3 because it's larger. Okay, and we see here it is greater than or equal to. So in our answer, x will be greater than or equal to, or less than or equal to, or if you're writing it as an interval, it will be with the square brackets. Okay, so that is 2, that is 3. So we want everything smaller than 2, or equal, again, from the question. So that takes care of that bit. And we want everything larger than 3. Okay. Or if you want to write it as an interval, you can do that as well. But here we can't write it as a single interval. It's going to be 2 intervals, one for the left, one for the right. So it will be everything up to 2 inclusive. Union. Have you seen union before? You have seen. Union 3 to infinity. Okay, so from minus infinity to 2, that's this bit over here. And then 3 to infinity, that's the other bit. Okay, so because the interval split up, our answer will also be split up like that. Okay, any questions so far? Yes. No, critical values, all of that side working. I'm not worried about that. Okay, you can use whatever method you want to solve this. I'm just interested in like the final answer here. Okay. Yeah, so a lot of these problems, there might be more than one way to do it. If it's mathematically correct, I'm happy. Okay, any other questions? Too hot for questions. Yeah. Yeah, I'm sweating as well. Okay, next bit, rational inequality. You may have not seen this in matric, I don't know, but we'll go through it anyway. It's a pen. Okay, so same idea as linear inequality and polynomial inequality. We're trying to solve for possible values of x. But here, the question is in terms of a rational expression, the stuff we did yesterday. Rational. Hi. Yeah.
Another student here.
Okay.
But he didn't participate for
okay,
lecture.
That's fine. Just have a seat.
His mother is waiting outside. So
oh, is he going? Okay.
Yeah. So you can catch up on the work later. You can email you. And,
yeah.
Or
did you have access to the loan page? Yeah. Okay. Okay, sure. Just check there. You'll see my contact details. Send me an email. Okay. If you need to go, you can go. Okay. Okay, rational inequalities. Okay, again, same game. We've got something less than or equal to something we want to solve for x. But in these cases, it's not going to be some linear thing. It's not going to be a polynomial. It's going to be a rational expression, like the stuff we saw before. So again, by example, number 1, x plus 1 over x minus 5 is less than or equal to 0. Okay, now just looking at this, you might think it's not so bad because you can multiply by the denominator, clear it. We can't do that. So big warning before you start getting ideas. Okay, we cannot clear the denominator, and I'll go through why. Okay, who thought you could do that? No one. Okay. Okay, we can't clear the denominator. Yeah, sorry. Okay, so usually the first idea is we've got x minus 5 in the denominator. Let's multiply both sides by x minus 5. Okay, and then that will get rid of the bottom. We can't do that. Why? Well, because x is unknown. We don't know what it is. So x minus 5 is also unknown. We don't know what it is. It could be positive. It could be negative. We don't know. If x is 6, well, then it is positive. That's fine. If x is 0, well, then that's going to be negative. What happens if we multiply both sides by a negative? What happens? If I have a is less than or equal to b, and I multiply by minus 1, what happens to the inequality? It changes, yeah. So in some cases, the inequality stays. Like if x is 7, the inequality is going to stay. But if x is 0, the inequality is going to flip. But we don't know what x is, which means we don't know if it's going to flip or not. So just adding to the warning, we don't know x, which means we don't know if, in this case, x minus 5 is positive or negative. Okay, and if we don't know if it's positive or negative, we don't know if the sign is going to flip. So we don't know if the inequality flips. Okay, and we're stuck. We can't do that. So instead, we're going to leave it like this and work with what we've got. So there are 2 steps to answering this. So step 1. Okay, this is just one way of answering it. Of course, if you've got your own way, please feel free to use your own way. Step 1 is we look for where the numerator and denominator are 0. Okay, that's just like before when you find those critical values. Okay, but here, instead of just having a quadratic with critical values, we now have a rational expression. So we have to look at the top and the bottom. Okay, find where the numerator and denominator are 0. Okay, just like how you would find the critical values. So in this case, it's quite easy. For the numerator, it's going to be minus 1. For the denominator, it will be 5. So for the numerator, we have x is minus 1. Okay, again, like your critical values, listing them out. And your denominator, we said that was 5. Okay, so we got these 2. If the top and the bottom was quadratic, you might have more possibilities. Okay, but here the top and the bottom are just linear, so we got one solution for the top, one for the bottom. If the top was quadratic, you would have 2 for the top, 1 for the bottom. Okay, but you just list all of them. Okay, so that's step 1. Step 2 is we draw a number line Okay, exactly the same as how you do with those critical values. So we're going to have some number line. Yes, yeah. Sorry, this pen. I think the battery is dying. Okay, but all of this should be familiar, right? You find your critical values, you draw your number line, and then we need to see where the function is, positive or negative. Okay, so we've got our real number line. We've got two possibilities here, -1 and 5. Again, there might be more. So let's say over here is x is -1. Over here, let's say x is 5. Right, again, you've seen that before. Now, what we want to do is pick values between these points and check if the function is positive or negative. Okay, so let's pick x equals -2. You can pick anything on that side, but -2. If we substitute that in, we end up with 1/7, which is greater than 0. Okay, just sub it in, you get 1/7. So here it is positive. Okay, we can pick something in between. You can pick whatever. Let's go with x equals 0. We get -1/5, which is less than 0. So this portion is negative. Okay, and finally, something on the right there that is larger than 5. Let's pick 6. Okay, you can pick 7, 8, 9, whatever you want. We end up with 7, which is greater than 0. So this bit is positive. Okay, so that tells us the sign of the function. How does that help us? Well, here's the function. We want to know where it is less than or equal to 0. In other words, we want those intervals where it's negative. So we just go back here and we see, okay, now this part is positive, this middle part is negative, this other part is positive. We want this middle part. So the answer will be -1 less than or equal to x less than 5. Okay, why less than 5 and not less than or equal to 5? If we go back up here, what happens if we substitute 5? Yeah, we start dividing by 0. There's problems. So we can't include 5. -1, you can substitute that, no problem. But 5, there's a problem, so we must exclude it. All right. Any questions on this one? Okay. Same working as you would have done with your critical values. Okay. Example 2. Okay, a little bit more difficult, but same idea. We have 3x plus 1 over x plus 4 is greater than or equal to 1. Okay, in the previous example, we had less than or equal to 0, and that made things pretty easy because we just want to see where the function is below 0, where it's negative. Here, on that side, we've got a 1. Okay, that's going to make a problem for us. So what we do is we take everything over to one side so that it looks more like this first example. Okay, so that's always the first step. Get it to look like this, where it's either positive or negative, depending on which way that goes. Here, it doesn't look like that, but we can make some changes. So this will be 3x plus 1 over x plus 4 minus 1 is greater than or equal to 0. Now that we've got the 0 on that side, we can follow as before. Okay, but here we're trying to take the difference of two fractions. It's not going to work because the denominators aren't the same. So this 1 we're going to write as x plus 4 over x plus 4. Now the denominators are the same, we can add the fractions. So let's do that. So 3x plus 1 over x plus 4 minus x plus 4 over x plus 4. Okay, denominators are the same, we can put the fractions together. Okay, so we end up with 3x plus 1 minus x minus 4. Yes. That's pen again. Okay, so minus x minus 4, that becomes the numerator. The denominator stays the same, and then we carry on as normal. Okay, there we go. Over x plus 4 greater than or equal to 0. The numerator we can clean up a bit. 3x minus x and the 1 in the minus 4. We can simplify that. So we're going to end up with 2x minus 3 over x plus 4. Okay, and now it's in that correct form that we want. We've got some rational expression, either positive or negative. Okay, so it can be greater than or equal to 0, less than or equal to 0, as long as you got the 0 on that side. Okay, so we go through the steps again. Critical values, that's where the numerator and the denominator are 0. So numerator, okay, 2x minus 3 equals 0. We get x equals 3 over 2. Oh, again. Okay, so we get the 3 over 2, and the bottom, easy, just the minus 4. Yeah, I think it's properly dead now. Maybe that's a good thing, then we can stop. Okay, well, that's not working. Let's stop today. Okay, I'll leave the rest for homework, and then we'll carry on tomorrow. I think it's getting way too hot to carry on anyway. Okay, so finish this for homework. Then there's another one for homework, but I'll just add it on when I upload the notes. And then tomorrow we'll go through absolute value equations and inequalities. Okay, if you have a look on the Learn page under Notes, there's a PDF called Algebra. Okay, we've been going through that. If you want to start going through absolute values, there's the section there. It's the last bit on Chapter 1. Okay, under the Algebra Notes. Okay, any questions? All good. Okay, so we'll leave it at that for today.